Professor, we have 25 students now out of 40. I think you can start. We have more than 50% of the students.
Oh, okay. Okay, thank you very much for this calculation and for the quorum. And thank you, Trump, for everything anyway. Dear all, it's a pleasure to meet you again, for this last session of the course, it is session number 5. We went on Saturday on session 4, okay? And today we'll go through some other topics and try also to conclude at the same time, coming back on the original architecture, dealing with some questions, and also on the exercise I started with 2 sessions ago on work calculations and multiples. So if we had a look on the first slide to the first topics before moving to the architecture, the questions, and the exercise, we have here 4 main elements. The first one is a presentation of interest rates curves. Perhaps you will ask the question, why do we have to do that? But I think you will understand very quickly that they are very essential in all these calculations and design of financial resources or financial structure. The second is the leverage. Leverage is very central in finance. And we know we have 2 categories of leverage. One of them you probably heard about in preceding courses in this program, perhaps with Olivier Grosard, but also in your bachelor studies, which is about what we call operational leverage or break-even analysis. It's generally part of courses in cost analysis. And we will go through diagnosis and financial structure, taking into account these 2 effects, these 2 leverages, operational leverages and financial leverages. The third topic will be about dividend policies, and we have afterwards questions about dividend policies. But dividend policies and models, which is one way to try to find cost of equity, for example, or the long-term growth of a firm. And last, we integrate all these elements in a basic presentation of valuation models, which will be a transition, between this course and the following course we teach together, we work on together, which is about company valuation. So that's what I want to do today. Remember what we did up to now. We had 4 sessions together. The first one was mainly on financial plan and investment decision. We tried to add more to, I would say, traditional calculations like NPV, internal rate of returns, and so on, and to design the kind of architecture integrating all the elements which are necessary to design a financial policy. Second session was about financial analysis and how to use financial analysis into the calculation of financial need or financial resources and financial design, of course, of a policy. We went also during this session 2 into a presentation of long and medium-term loans and hybrid products. Session 3 was mainly on leasing, multipliers, calculation of cost of debt, and also an introduction to weighted average cost of capital calculations. Last time, on Saturday, we went through equity issues, trying to explain how it works, why we go through equity issues for free, why do we go through equity issues for cash. What are the consequences in terms of dilution? Dilution of wealth, classical dilution, which is generally well presented in the textbooks, but also dilution and control, and the fact that the CFO has to manage simultaneously, at the same time, which is the difficult point, in fact, the both dilutions of control and dilution of wealth. And so today we will integrate new dimensions on interest rates, on leverage, on dividend policies, valuation models, coming back on the architecture and trying to explain how to integrate all these elements into the design of a financial policy. And I hope to have time enough to go through some questions already raised in different past exams, and also to have a look to one of the exercises we started with in session 3 with 2 questions out of 4. So that's where we are. That's what we are going to do. So first, let's have a look to point 1. And point 1 is on, that's it, it's here, on interest rate curves. Okay. So we already said that, but I think it's useful to underline this point again. First point here, in economic and financial theory, the global shape of a curve is demonstrated. It's not empirically designed, but it is demonstrated. It's a demonstration, but you can also have a look, and that's what we will do in a few minutes, to different interest rate curves on the market today. A growing curve is moving up, and after a few years, it moves towards an asymptote. That means, in fact, clearly that that short-term interest rates are lower than medium and long-term interest rates for a well arbitrage on a well arbitrage market, and also for the same firm or firm belonging to the same class of risk. So this has been, demonstrated through theory and has been also estimated through empirical research. Point 3, in the classical curves, all interest rates are positive, even if they are, in some cases, very close to 0. The situation right now, the situation we have known for the last 2 years, is very different, and it is really an exception in the financial history, and you should think about that. Central banks had liquidity, and they had added more liquidity than ever on the markets and to the banks. And short-term interests decreased and became negative in some cases. Even if the slope of the curve is still increasing. That means for no zero risk, let's say, issuer or very low risk issuer, like the best countries in the world in terms of financial situation, you will find negative interest rates up to 5 or 7 years maturity. That means, when, for example, the Japanese or German governments issue bonds in the market, instead of paying an interest, it receives an interest. It is clearly an incentive for these players to issue more bonds. increase their debt level. It's good policy, at least in the short term. Is it a good policy in the long term? It's difficult to say right now. We don't have that kind of experience, but we can have a question mark on that point. Now, just to look to the case of some countries. We find different groups of countries, even if it is, difficult to put them in different categories. We find dominant economic players with high growth rates at the end of the crisis, with growing inflation, but no negative interest rates. You have two main examples, the US and China. It's a more classical situation than for the other large players in the world, more classical in terms of history, financial history, and also in terms of financial theory. The second point, you find a group of developed countries with low growth rates, low inflation, and difficult demographic problem to solve. The main example is Japan. And they get negative interest rates below 7 years maturity. It means from 0 maturity to 7-year maturity. When the Japanese government issued debt, he received an interest. He doesn't pay an interest. Third, you have a case of the continental European countries, low growth rates, low inflation, a demographic situation which is better than Japan, for France at least, and the same central bank for all these countries, all the Eurozone countries. And you find negative interest, at least for short-term interest, and even for Germany for 6 or 7 years maturity, like for Japan. And you have a case of Britain, which is a kind of opportunistic policy there. They have an independent financial model now, which is probably connected to Brexit, partly at least. And they show positive interest rates, a bit like the US. It's more similar to the US than to the other European countries. So you find different curves. It means different situation in terms of position of the borrower and the lender, because what you find for zero risk, issuer has a great influence on all the loans and financial operations for the firms and for the banks everywhere in the world. Now, if we try to understand what it means, today interest rate levels and liquidity available to the bank and other markets are priorities for all valuations, for bonds valuation, for share valuation, for real estate valuation, companies, banks, any kind of asset, any kind of player. And one of the questions, here is, which is very central, is what are the more important interest rates? Are they the short term or the long term? If you have a look to financial theory and what I said before on the balance between the bond market and the stock market, it is admitted that it is the long-term loans which are the reference and which can be used also to calculate with premiums, integrating premiums, cost of equity. But it seems today that we have a change and that each short-term interest rates are as important as long-term interest. And this is quite interesting because, interest rates on the long term are the result of the equilibrium between the lenders and borrowers on the market. This is one of the main resources used to finance the investments. On the contrary, short-term interest rates, are fixed, managed by central banks, and are not really connected to the real economy. Of course, one way or another, these two categories of interest rates are connected because you can borrow on the long term and lend on the short term. You can make arbitrage between the two categories of rates. But basically, they are fixed in different ways. Second, the policy are designed by central banks, mainly for short term, and mainly a few of them. That means all these short-term interest rates are in fact managed by a kind of club of players, which are the largest main central bank in the world. The US one, the European one, the Japanese one, the Bank in England, and probably in the future, if it is the case right now, it's difficult to understand, the Chinese central bank. Remember also when we have to go for calculations and compare different bonds, issues, loans, you need a common reference. And the common reference is the 10-year government infinite bond issue. It means when you want to compare two different loans or two different issues of bonds, you have to swap them against 10-year infinite bonds. That's the general principle which is admitted everywhere in the world to make comparisons of cost of bank loans or of bond issues. So that's a feature. Now let's have a look, two different curves, just to have some example. This is the US one. And you see what's happened to the US one. The US one is completely positive, whatever the maturity is. It's still very low and very short-term issues on monetary market. And it's increasing, not regularly. It's not some funny situations, for example, 7 or 8 years. But globally, the trend is positive and is moving towards an asymptote around 2.4, 2.5% for long-term issues. So it's quite normal with volatility, in the medium term. Now, if you move to the Chinese one, it starts with short-term rates, which are much higher than the US. But after that, you have a growing curve, positive slope, more regular than the US one, which means, it is more carefully managed by the central bank, under the power of a central bank. There's less volatility on this curve. But anyway, it is the same shape and same results. We are moving towards something like 3.7, on 30 years issues. But we start with 2.6, which means all the interest rates here are positive, and the slope is also regular and positive. Now, try to show you the next one if it works. Yeah, Japanese one. What's happened here? Well, you see is that up to 7 years maturity, interest rates are negative. And after that, your trend is the same, the slope is very positive. But for 30-year maturity loans, zero risk, we're still zero risk, it's only 0.66%. It means it's very low compared to what you found in China or in the US. This is the case of a developed economy, low growth rate, demographic situation, which is really a long-term problem of the country. It means less demand or limited demand for investments compared to the available financial resources available. You move to Germany. The trend is very similar. Even here, still have negative interest rates for 12 years maturity, longer. And you don't have the same regular trend as you find with Japanese or with the Chinese, but the kind of volatility you find also with the US. Yeah. But anyway, the central elements, negative interest rate for short and medium term, and positive interest afterwards. And the long-term interest rates, which are not very high, 0.45 is very similar for 30 years maturity compared to the Japanese. And this is France. France is very connected to Germany. We have the same central bank, we have the same monetary unit, the euro, and the global shape is similar, but with differences, we have negative interest rates only below 7 years. And after that, it goes up quite quickly, up to 30 years. But we even find here 50 years maturity issues with an interest rate which is a bit lower than 30 years. And you can probably explain, 50 years compared to 50 years by the very limited number of issues at that point, it means there is no real equilibrium on the market. Then let's move here after the French one to the British one, and this is Britain. And the British one is always positive. There is no negative interest rate on the British market and on the pounds, even if it is very low for the short-term maturities, but it goes up very quickly, afterwards, and is completely stabilized after 20 years or even after 15 years. Differences in the interest rates is very limited. So it's more high slope, high positive slope before the 15 years, and after that, it's really a flat curve we find here, which is very specific, more similar to the US than to the European market in Germany and in France. That's what you find. So, how can we analyze this? Why is it interesting? Why is it interesting for us? It is interesting first because we have this phenomenon of negative interest rate today, which we don't find, in the preceding periods of history, even during crises or conflicts. We didn't have it. So this is very specific and can be explained only by the policies enforced by the central banks in order to fight again the pandemic and its consequences. But however, you understand that even if the policy are very similar, the consequences are not exactly the same for different group of countries. They are not, you don't find negative interest rate in the US and in the UK, but you find negative interest rates in Japan, in Germany, in France also. So that's the difference. That means also the signal or the incentives brought to the different players is very different when you still have, even if they are low, positive interest on short-term maturity and negative interest. That means also that the equilibriums of the markets are not, made by the same, are not made the same way. Second, you understand that long-term interest rates are quite low in all these countries. They are quite low, which means that the final demand for long-term resources, it means to finance investment, is very limited compared to what we knew in the past. And if we try to explain that and have a look to the level of investment in all of these countries compared to what they were 10 years ago, for example, they are much lower. That means we're investing less than before everywhere, which means, at least in these countries, which means that in the medium term or in the long term, probably growth rate will decline again. Investment and innovation are the key elements to explain the evolution of a growth rate. What does it mean after that for firms? For corporates, it means that it's a good opportunity to issue debt. And if you have a look to the different analysis available by the OECD or by the IMF, you understand that large firms, even those profitable, they have issued large amounts of new debts in the last 2-3 years. The CFOs understood very quickly that it was good business, to go on the market, and even if they don't use very short-term maturity, when we use medium and long-term maturity, the interest rate paid is very low. And they can, of course, expect that on a period of 8, 10, or 15 years, the average cost of a debt calculated through the interest paid will be lower than the rate of inflation. And this is the key point, if you have an opportunity to be financed by debt at an interest rate which is lower than the rate of inflation, it's good business, whatever you do with your cash, what are the decision you make to allocate this cash. So that means that in many cases we have underinvestment curiously, but you have over situation or over situation of debt. Too much debt, but not enough investment. And when you have that kind of situation, what do you find in the end? You find firms, large firms, with large amounts of cash available. And this large amount of cash available, of course, is going back either on the market short term, they lend, they are lender, they became bank, or they have more deposits in the banks, which means the situation explained partly, at least, the over liquidity of many banks, at least in the developed world. So if you are in a business which is growing quickly, like information systems, for example, it's a great opportunity to be financed by debt today. So this is the first element I wanted to show you, and I wanted you understand that interest rate level in absolute value with a comparison between the short term and the long term, because they are fixed in different ways. Compared also to the potential return obtained on investment, there are key elements of decision of the CFOs. You understand also that if you are very well rated, you have a very good AAA or even AA, you can issue that at zero or negative interest rate. And this is a great incentive to issue that, even if you don't know what to do with your debt. After that, you will see what's happened. Let's explain also the other investment today in real estate everywhere in the world. And if you had a look to your mobile this morning, your computer, you understood that the problem is coming in China right now, because when you overinvest, in real estate at a point in time, you have loans which are given to investors, which will not be able at a point in time to pay back. And this is what's happened in China. This is what happened in the US in 2008. So the situation in terms of interest rates, which occur sometimes, on the financial markets, is an explanation or potential explanation of financial crisis, either past financial crisis or financial crisis to come. Now, I'm somewhere here, 7, 8. Yeah. I will move to slide number 12. And slide number 12 is the second topic for today, after interest rate curves and the consequences of these curves and the risk of crisis, which is behind, let's have a look at the financial leverage. And you will understand after we go through a formula, but there is some kind of connection of link between the interest rate curves and interest rate levels, financial leverage, and the global level of risk of firms. So let's start here by the beginning. What do we know about financial leverage? First, we have two kinds of leverage. What we call the operational leverage, you can call it break-even analysis if you like, and financial leverage. The second point here, the operational leverage allows the calculation of the break-even point, which means the situation with no profit and no losses if you don't take into account the financial decisions. That means you have a look only, to the elements in an income statement which are above the EBIT. That means there is no interest rate incorporated here or taken into account. There is no dividend policy. There is no other non-recurrent element. And the problem is to understand, to calculate, to know if at that level, you have an equilibrium between the revenues and the costs. So that's the problem of break-even analysis. And operational leverage deals with this part of the income statement with an analysis of the fixed costs and the variable costs. And as we know, and we heard before, we know that fixed costs are connected to the risk level. I mean, the higher the percentage of fixed costs in your total costs, the higher the risk is. But remember that risk is not only a kind of negative element, it could be positive or negative, but it is a kind of symmetric concept. And that means when you have high fixed costs, you have a risk of losing, of losses, but you have a risk also symmetric risk, which is to have very high returns. So the idea is to cut into two parts, the income statement, and to say, okay, we can have an analysis of the leverage effect, fixed costs, variable costs, break-even on the part of income statement between the level of sales and the level of the EBIT. And we have a second analysis, which is dealing with what's happened in an income statement between the EBIT and the bottom line. And then we understand that very often, most of the cases, the two main elements, in financial terms, are a payment of interest, which are fixed costs, or very close to fixed costs in general, and you pay also dividends to the shareholder, which is fixed each year, as you know, by the meeting, during the meeting, the annual meeting of the shareholders, and which can move from one year to the other. It depends on policy, it depends on the circumstances, it depends on the level of operating or net earnings. It's not fixed as the interest to be paid is. So you find again the analysis in terms of fixed cost and variable costs, fixed cost being connected to the debt level and variable cost to the total equity level. So this is the same principle of analysis we have applied also for the operational leverage. So in fact, if you want to simplify and to summarize, leverage is an analysis of fixed costs and variable costs, first at the operational level, which means income statement between the sales level and the EBIT, and second, as far as the financial position is concerned, between it's an analysis of fixed costs and variable costs between the EBIT and the bottom line of the income statement, the operating income or net earnings, as you prefer. So this is what it is. So we will see that we're able to aggregate these two measures, and that particularly financial leverage formula is useful to forecast the financial risk and make the necessary decisions and can meet to decrease, if it is possible, the level of debt, or to hedge this level of risk using swaps, for example, of debts versus equity, or using convertible bonds also. So, at the same time, it's quite simple in terms of basic calculation for the operational leverage. And when you start dealing with the policies to enforce, in order to reduce your risk level, because you have high personal risk and you have also a high financial risk, that means complex hedging decisions, and you have to have good knowledge if you want to deal with this decision of swaps of debts, swaps of debt versus equity, a convertible bond issue, and structure. Next, I want here, in order to try to be more clear on the financial leverage, not on leverage as a whole here, financial leverage, which is central topic for this course. Using a small example. That is what we will do here. So in this example, we have a company with a CFO, which is not something new. The CFO of the company wants to finance a 600,000 euros investments. And we try to simplify here. But anyway, if you have more potential solutions, the approach will be the same. Calculation will be more complex. In that case, the CFO has three potential financial structures. He can finance this investment using three different mix. The first one, called A, is 100% equity. The second one, called B, is 50% equity and 50% financial debt. And the third one, C, is 75% of debt and 25% of equity. You understand that they are very different here. It facilitates the conversion. But anyway, if you choose, instead of having 25, 75, you had something like a 40, 60, you will find the same conclusions. Another element is that we suppose that we have already solved the problem of the operational leverage. The choice of costs, means, for example, to have more investment for automatic production or not. And the EBITDA, which is calculated here, is 300,000 euros. And the depreciation level, classical depreciation amortization level, is about 100,000 euros a year. Very simple data. The interest rate here, which is a long-term interest rate, it's an investment, that's a 10-year interest rate, is about 8%. We understand that we are not in the present situation of developed countries. It's more an emerging country rate, 8% a year, and the tax rate is very high, here is 50%. And the tax rate, as we know, is a parameter which can be modified during the life of an investment, which means there is uncertainty at the level of the tax rate, of course, but also of all the results depending on the tax rate. We know also that the nominal or original value of shares is 1,000 euros. So we have all these elements, and we try to go through the exercise using these elements. So we are now at point 4 here, and at point 4, we try to have a short table with calculations with A, B, C, which are the three financial mix. And remember that A is 100% equity, B is 50% equity, 50% debt, fixed interest rate, and C, which is 25%, 75%. Okay, so they are very different. Anyway, the level of investment is the same. There is no connection or no link between the financial mix and the financial decision. Remember that this is one of the basic principles you find in the financial theory is that, we have a theorem which is also demonstrated. It is demonstrated, which is that we have first an investment decision, and when the investment decision is done, we will move to a financial decision, and the financial decision doesn't have any impact or influence on the investment decision. This is what we call the separation theorem. Separation theorem is one of the most important theorem in modern finance. So after that, you can discuss about that point, if it is really true. And of course, you find a good example of situation which is not in line with the separation theorem, which is the leasing contracts, where you can argue that when you can finance an asset by leasing, you increase your capacity to extend your debt, you increase your debt capacity. So that means there is some connection between the investment and the financial resource you can obtain. Anyway, it is validated in most of the cases. Second line here, you have got the equity, and you understand that the equity, which is used for 100% of the of investment in case A, is equal to 600. For 50% in B, it's for 300, and for 25% in C, it means 150. 600, 300, 150, you find the three cases there. Debts, of course, debts level are 0 when it is 100% equity, column A, 300, column B for 50% of the total mix, and 450 in the third case. In this data table, we integrated also the interest paid per year and the number of shares. Interest paid is, of course, 0 when you finance by 100% equity. It is 8% of 300, which is equal to 24 in the second case B. 300 multiplied by 8% is equal to 24. And it is 36, which means 8% multiplied by 450. And this is what you find here in case C, with 75% of that. 8% of 450 is equal to 36. So you have got this line of interest, 0 for A, 24 for B, 36 for C. This is what we find. Okay. Number of shares right now. If you issue your share, which is a parenthesis, which is acceptable, for a new project here at the nominal value. For 600,000, when it is financed 100% by equity, you have 600 shares. For the same amount, 600,000, when it is financed 50% by equity, it is 300. And in the last case, C, it is 150. 25% of 600 is equal to 150. So you have an increase of 600 shares, an increase of 300 shares, an increase of 150, depending on the mix, financial mix you use. That means also, and this is not introduced in that example, that the consequences of dilution of wealth for the original shareholders will not be the same. And you can argue that if there is a good expectation of, in terms of return on this investment, shareholders, original shareholders will be like better C than B and A, but we'll come back at that point in another slide. Okay, so you have now the basic data, and we have to move, to the next slide. The next slide is somewhere here. We were here, and now we are here. Okay. So this is the calculation of the earnings. I call them net earnings or operational earnings or operational income. It doesn't matter. That is bottom line of the income statement anyway. So the EBITDA is equal to 300,000 in all the cases, A, B, C. The depreciation amortization level of the asset is not a function of the financial mix. It's completely independent of the financial. It's always, whatever happens, whatever is the decision, it's always 100,000. And depreciations and amortizations are calculated by rules coming from the accounting system, coming from tax administration, not from the banks or from the financial markets. So you find the EBIT here immediately after, and the EBIT is 200,000 in the three cases. Same kind of EBIT here, same level of EBIT. Now you have in the second part of this table, calculation table, you have a few differences, okay? And this is due to the interest rates. As we calculated, the preceding slide, the interest rates here, level for 1 year on the project with the three different financial mix, 0, 24,000 and 36,000. And with this data, you get here this line interest rate 0, 24,000, 36,000. You make the difference between the EBIT and the interest rate, and you get the earnings before taxes, 200,000. 200,000 in the first case. It means there is no interest rate, there is no debt, and in this simplifying calculation table, you find an earning before taxes which is equal to the EBIT. Second case, you have 200,000. You reduce this number by the level of interest, 24,000, and you get 176,000, 200,000 minus 24,000. It's 176,000. If we take the last case here, 200,000 minus 36,000, it's 164,000. And what you see, of course, is that when we increase the level of debt, the percentage of debt in the financial structure, we increase the level of interest rates and we reduce the earnings before taxes. That's one of the consequences. Then you get the taxes, and here we have very high tax rates, 50%. Tax rates, if you have a look at the country into the last 50 years, they have been moving from very high data. 50% is easy for calculation, but in many countries, you find at the point in time, 40 years ago, you find 40%, And now in some countries, it's very low. For example, in Ireland, and this is the problem of OECD today, it is 12.5%. And of course, when you have 40% tax rate or 12.5, you have very different consequences. Okay. So with this element, you can calculate the earnings after taxes. It means the bottom line of your income statement. and it is 100,000, 200,000 minus 100,000, which is equal to 100,000. First case, 100% equity. Second case, you find 176,000 minus 88,000, which is 88,000. And in the last case, C, with high level of debt, you have 164,000 minus 82,000, which is equal to 82,000. So it's quite easy to understand, you know, that when you increase the debt level, you increase you increase the amount of interest paid, you decrease the earning before taxes, decrease also the tax level, but also decrease the earning after taxes. And when you have a look to this table, you probably the accountants think that it is much better to be financed by equity, you know, because at the end of the process, you know, you have higher earnings, even if you pay more taxes than with the case C, where you get 75% of debt. What do you want? Do you prefer to have a structure with a limited amount of debt, high taxes to be paid, but high earning after taxes, or a very different situation in case C, where you pay less taxes with lower earning before taxes and lower earning after taxes? You understand that the position of different players could be also different on that point, and that we will be later in the middle of contradictions. So we are at the level of slide number 14 here, and I will move to slide number 15, which you will find here. Slide number 15. Well, you find another calculation table again. You know. And we start with the result we have found, you know, on the last line of the preceding calculation, which is the level of net earnings after interest, after taxes, which is 100,000 for A, 88,000 for B, 82,000 for C. We know what is the number of shares issued, new shares issued in each case: 600 in case A, 300 in case B, 150 in case C. 600, 300, and 150. That's what we find. Yeah. Okay. So you just compare, you make a division, you know. And for A, 100,000 divided by 600 is 166. Means it's 166 euros per share. In the second case, it is 88,000 divided by 300, which is 293. And in the last case, it is 82,000 divided by 150, which is 546. And what you understand, you know, is that the net earning per share is increasing quickly from A to C. You increase the level of debt and you increase the net earning per share. And that also means that if you use a simple model we have introduced, with a PE which is stable, which is dependent of the financial structure, the value of the company will increase when you move from A to C. More debt, higher level of debt, higher net earning for the higher net earning for the shareholder, more wealth created for the shareholder. Now, if you have a look to the cash flows, of course, or at least a proxy of a cash flow, you can come back to my table on the cash flow, which is more detailed than this one. It is calculated here with a total of net earnings plus the depreciation and amortization. And you have 100,000 net earnings in case A, plus depreciation, which is 100,000. And the total here is 200,000. If you have a look to B, case B, you get 88,000 for the net earnings and still 100,000 for depreciation and amortization, because depreciation and amortization is not, remember that, it's not connected or correlated with the financial structure. And in C, you get 82,000 for net earnings, 100,000 for depreciation and amortization, you get 182,000. So, if you have a look to the results, what you find is that cash flows are declining like net earnings at the level of the firm. When you move from A to C, cash flow of the firm, the net earnings of the firm are declining when you increase the level of debt. But now let's make the calculation again per share. And if you divide the 200,000 you find here by 600 number of shares, you get 333. If you do the same thing with in the second column, you get 188,000 divided by 300, which is 626. And in third case, you get 182,000 divided by 150, and you find 1,213. What does it mean? That's the absolute value of the firms, of net earnings and cash flows are declining when you increase the level of debt. The higher the debt level or the debt equity ratio, when you increase the level of debt, the lower is the level of net earnings or cash flows of a company. But now, if you make the same analysis at the level of one share, what's happened? When you have a decline in the level of, if you have an increase, in the level of debt, you have also an increase in the level of earning per share and of cash flow per share. Okay. It means the situation is not the same at the level of a company and at the level of the individual shareholder. There is some kind of contradiction between the interest of a company and the interest of the individual shareholder. So we have already found, here in the three tables we went through, in particular in the last two, different elements of interest. We know that the net earnings is declining when we have more debt. The higher the debt, the lower the earning after taxes. We know that the cash flow, global cash flow, is also declining. But when we move, to a situation of analysis of the individual shareholders, not of the company, you have a different effect, a different consequence. The net earning per share and the cash flow per share are increasing and very quickly when you introduce more debt. When the debt equity ratio increases, the level of cash flow and the level of net earning per share increases, which means that you assume that the PE, at least in the short run, is not a function of the financial mix. You increase also the value of the company. So you understand, we are in the middle of contradiction. And this is one of the many issues of the analysis of financial structure. Now, I tried, to put on a sheet of paper, the different elements here. And what you see before having making any kind of analysis is that we have a nice graph with 3 straight lines, and the straight lines cross each other, it seems at least, at the same point. So probably there is in that kind of analysis a specific point, which has a financial specific characteristics. So what have we done here? What have we done? We have said, okay, we have the zero debt, 100% equity situation policy, which is A. And what do we know on A? We know that and this is what is shown by one of the preceding calculation here. Let me see, yeah, it is here. We know that in this, with this mix, 100% equity, the net earning per share is 166. Net earning per share is 166. And this is for a level of EBIT, which has been calculated somewhere here, which is 200,000. So, in fact, we are able in a few cases to put on the graph point and point for A for this level of EBIT. So for 200,000 here, and 200,000 will be somewhere here on the EBIT line. We have different points, and for the first one, for A, 100% equity, it is 166. So on this axis, you get the earning per share. On this one, you get the EBIT. And at the beginning of this analysis, you know the results of the preceding calculation, which means here 200 for 200 level of EBIT, 166 level earning per share for A. And if you go back to B, it will be 293. And for C, it will be 546. My graph is a bit simplified, but you understand that you have points which are much higher. But anyway, we already know one point. After that, it is clear that you can modify these calculations, and you can modify calculation modifying the level of EBIT. It is not so clear that the EBIT will be always 200,000. And the question, for example, is what happens if the EBIT is equal to 0? If the EBIT is equal to 0, in case A, I go back here. If EBIT is equal to 0, just because above you don't have the same level of sales, for example, EBIT is equal to 0. What's happened afterwards? You get earnings before taxes equal to 0, taxes equal to 0, earning after taxes equal to 0. And if you move to the other table, you will find net earning per share equal to 0. So that means that the point 0, here will be part, of a straight line, which represents, the earning per share in function of the EBIT. So what you have done for the first financial mix here, you can do it for the second one. It means for B, which is 50% debt, 50% equity, you already know one point, which is for 200,000 level of EBIT, you have 93, excuse me, 93, 293. So you are able to put that point on the graph. But if you want a second point, on the line, the easiest thing to do is to say, okay, now let's come back to the calculation here. And for this calculation, I start with my hypothesis. I've got an EBIT which is equal to 0. What does it mean? It means if you have an EBIT equal to 0 in case B, you still have the interest rates, 24,000. That means that the earnings before taxes are equal to minus 24,000. Taxes equal to 0. Earning after taxes equal to minus 24,000. If you move to the second table, you have minus 24,000, still 300 shares. You make the division, 24,000 divided by 300, it's equal to minus 40. So what does it mean on your graph? It means that you have a point here, which is minus 40. When the EBIT is equal to 0, your earning per share is equal to minus 40. And we know that this is a straight line. So we know 2 points. That means with 2 points, we are able to put a straight line on the graph. And we understand immediately that this is something very interesting. Why is it so interesting? Because now, on the second straight line, for B, 50% equity, 50% debt, you have several interesting points or situations. The first one is that the line for A and the line for B are crossing each other at a point which is easy to find if you have a good graph. And you will see later, if you like, that you are able to calculate. Okay? So that means there is a point somewhere where the earning per share for a mix with 50% debt, 50% equity is the same than for 100% equity financial structure. It seems, but we have to generalize, that the earning per share at this level of EBIT is completely independent from the financial structure. And that, of course, when we move to the right, it means when we increase the EBIT, the earning per share of B with B structure, 50% debt, increases at higher speed quicker than with the A case, it means with 100% equity. It seems that the debt equity ratio, or increase of debt equity ratio, for the same level of EBIT is a kind of element which accelerates the increase in the earning per share. On the other side, if you have a look at what's happened on the other side for A, which is 100% equity, as long as the EBIT, it means the operational return is still positive, you don't find any negative earning per share. So that means, the fact you are financed only by equity reduces your risk as long as your operational activities, the operational part of your income statement show at least 0+ result. You don't have any negative earning per share. It's a kind of, I would say, internal or operational protection, international hedging structure. Now, if you move to B, you understand that the earning per share is declining much quicker. And that for values, some positive values of the EBIT, it means some positive returns of the operations, some positive values of EBIT, in fact. You get earning per share which are negative. So if you transfer these simple conclusions in terms of risk, that means the A financial structure is less risky than the B financial structure. When you have a very positive EBIT, it means operational return, it's much better to have higher debt. When your operational return is low, even positive, it's much better to be financed by equity. It means that equities, an equity, very large majority, or even 100% equity in your financial mix is a natural protection, it's natural hedging policy against risk. Now, if you have a look to see what's happened when you have a look to see, you understand that for C, which is 75-25, we are in a situation which is very similar to B compared to A, but the fact we have a higher percentage of debt, higher debt equity ratio than in B, increases the impacts, all the impacts. When we have high EBIT values, we have very high earning per shares, and we have made a calculation in one of the preceding tables, something like 546 compared to 293 or to 166. Okay. On the contrary, if you go on the other side and say, okay, let's make the assumption again that now the EBIT is equal to 0 instead of 200,000. You get 0 minus 36,000. It means you get earning before taxes equal to minus 36,000, taxes equal to 0, earning after taxes which are minus 36,000, And if you move to the second table, you start with minus 36,000. You get only 150 shares, and the net earning per share will become very, very negative. It will be minus 120, 120, 120. So the slope of the line is very different what it was in the two preceding cases. We know that when we have high operational returns with this level of debt, it's much better. It's much better to have this high level of debt. If the operational return is very low and negative, of course, it's much better to be financed another way, mainly with equity, by a large majority of equity. So we understand what the impact. Now, the last element. We have been through these calculations, the first analysis, but we noticed also that on the graph, it seems that these three lines cross each other at the same point. And we can find this point in terms of EBIT level and earning per share level, doing two different things. The first one is solving a system of equation, and the second one is to try to understand what's happened. Remember that we have a 600,000 investment and 8% interest rate, and that the return, the 600,000 multiplied by 8% is equal to 48,000. And 48,000, as we know, if you put 48,000 in the first, in this table, you will quickly understand that if you have 48,000 as an EBIT level, here you will get 24,000 for taxes. Earning after taxes would be 24,000, and you divide by 600, it means plus 40. At least in that case, 100% equity finance, you know that for 48,000 level of EBIT, you will get plus 40 as the level of earning per share. But let's try the second calculation. Let's move here, to a second case, and it will be here, be 48,000 minus 24,000, which is equal to 24, and 24 divided by 2 is equal to 12, and 12,000 divided by 300 is also equal to plus 40. That means, we have validated what we found on the graph for an EBIT of 48,000 in the two first cases. We found, with this calculation, we found an earning per share equal to 40. You can check also these answers with the first case, which is C, with an EBIT here instead of 200,000 and 48,000, interest being 36, 48 minus 36 is 12, 12 divided by 2 is 6, and you get 6,000, and you divide by 150, and it is 40 again. That means it is clear that at a point which is 48,000 for the EBIT and 40 for the earning per share, we have something very specific, which is that the earning per share, basic of a calculation for valuations, basic calculation for return of shareholder, is completely independent of the financial structure. When you move to the right of this 48,000 equilibrium point, it is clearly of the interests of the shareholders to have to increase the debt level, the debt equity ratio. And below 48,000, it is just the contrary. It is much better to be financed by more equity, and if it is possible, by 100% equity level. So you understand that 48,000 is equal to 600,000, the level of the total level of investment multiplied by 8%, which is the interest rate. And of course, when we go for the calculations, we will find and demonstrate this situation at the point of level of EBIT, which is equal to the level of investment multiplied by the interest rate. We have always, whatever the financial structure is, the same return for shareholders. It is completely independent. So the financial structure is much more important for a firm where the return on operations, which is the EBIT, is different from the interest rate. If the return on operations is this return of operation is higher than interest rate, that means it's a good policy to use more debt than equity. And on the contrary, if we are in a situation where the return on operations is lower than the level of interest, it's much better to be financed principally by equity. So this is basic elements, of financial structure. You understand that the calculation is very simple. I did that in 4 slides, showing you the data. The first calculations of earnings, with the first conclusions here. Now the calculation of cash flows, net earnings per share, and cash flow per share, and another conclusion which is different from the preceding one. And I'm trying to summarize all that very simply on the graph, trying to show you that the decision you make in the choice of financial structure is dependent of your expectations, your forecast in terms of return on operations. It's a clear function which has to be taken into account. Now, let's try to summarize and discuss, some of the specific points here. Let's make a short diagnosis, in fact, of what I have found up to now. The first point is that the higher the debt level, it seems that the higher the debt level, the higher the return for shareholders. But we understand that we are in a specific case. In that table, we have a case with an EBIT of 200,000, which is much higher than the 49,000, which is such that the return on operation is equal to the interest rate. So this is true. We higher the debt level, higher the return per shareholder, but in a specific situation. If it was true in all the potential or possible cases, it would mean that we will be very rich, very wealthy. Second, so it is true with specific operational returns. Operational returns higher than the interest rates of debt included in the mix. That's what we demonstrated, the 8%. So when we have, operational returns higher than 8%, it is good policy. C of point 3 here. What is the preference of shareholders? What do they prefer? If you were a shareholder here, with the data we have, what is your choice? It is clearly structure C. You understand that with high debt level, you increase your earning per share, and that with rather constant, price earning will increase the value of your share. So shareholders very often for companies with good, high return on operations, they will prefer financial structure with high debt equity ratio. For bankers, it's much more difficult to conclude. Why is it more difficult? For two reasons, Of course, A or B are less risky than C. But it is also clear that C brings more interest to the bank. So very often, banks are in a position with contradictions. And in their decision, the bankers have to integrate this contradiction. What about risk? What about the interest? And it seems that here, for example, if you balance both financial structure B, 50% debt, 50% equity, will be better than A, no interest, or C, too risky. What about CFO's position? CFOs first, they have to present their results, performance, to the shareholders and to the annual meetings, so this is probably the first goal. But they have also to keep a low debt equity ratio to finance the investment to come. This is what we know, that's what we have heard of. They keep some kind of debt capacity available if they want to grow, making acquisition, being able to size a new technology. And debt capacity, low debt capacity is at the same time a key to finance easily new investments in the short term. But, it is also a key for them to be more independent from the board, from the CEO, and also from the external partners. So, they have two different goals. The goals of a shareholder, they want to adapt to the goals of a shareholder, to be in line with them, but they want also to keep debt capacity and a low debt equity ratio. So they cannot have both at the same time. They have to make choices. So that means if you compare now, what is generally the preference of shareholders? The preference, which is an equilibrium from the bankers between two different positions. And again, the equilibrium of the CFOs between different positions, maybe two different positions which are in contradiction. It's very difficult, to find, financial policy, a financial mix, which is acceptable, which fits to the rules, principles, goals, and constraints on the main partners in the firm. So, point 4 here, it means we have identified contradictions. They are different, they are non-compatible preferences between the different stakeholders, and here between the main stakeholders in the financial decision. The shareholders, the bankers, the CFO. And this is another part of finance. And you understand that all the goals here cannot be summarized in one element, which is to maximize the return for shareholders. Return for shareholders is important, but it's not the only goals and the only constraints. So it's another part of finance. It will not be part of this course, but we have a theory in finance, which is called the agency theory. And the agency theory, is dealing with that kind of problem. How to solve, this contradiction between the main players, the main stakeholders of the firm, how to find the equilibrium point, how to calculate a final decision, a final mix, which is acceptable by all of them, which is a compromise, which can be accepted by all the stakeholders. So this was also, presented in economic theory. Perhaps you heard of the name of this economist, which is Mr. Kölm, K-O-L-M, Kölm, K-O-L-M. And we have a graph representing the solution, which is called the triangle of Kölm, and which has been used after that by financial researchers to establish this agency theory. This is what I wanted to show you. Now you will see also, if you think to what's happened, in the real life, firms with different policies. It is clear that there's net equity ratio and the returns are connected, to different elements. The first one is a cycle. We have cycle of inflation, of interest rates. When the cycle of economic growth also. If you simplify, if you think that tomorrow, in the years to come, the economic growth will be high, what should you do? In general, you should argue that your EBIT level for operational return will increase and that your debt equity ratio should increase in order to obtain a very high earning per share and a higher value for the share of the company. If now you believe that we will have a crisis because the beginning of this crisis in China with real estate and the banks will develop and will be transferred to the banks all over the world. Now, if you think this hypothesis is true, will be validated in the months to come, you have data to be financed mainly by equity. And if at the present time you get a high level of debt, perhaps it's not too late to make an equity issue and to replace a large part of your debt by new equity in your balance sheet and to decrease your debt equity ratio. So one of the key quality of a CFO is to be able to adapt to this economic situation, to remain characteristic of the economic situation. Growth rate, but also inflation and interest rate. This is very central. Mm-hmm. So it's a great issue. You find also companies which are, in a situation of portfolio of assets, of operations, which allow them to increase their debt equity ratio compared to other economic sectors. There are those with long-term investments and nearly fixed income or incomes which are pegged to some kind of global economic data. This is the case for many infrastructures or players, companies belonging portfolio of infrastructure and delivering a service through this infrastructure. Electricity producer, for example. All the firms involved in the mobile information systems, transportation firms, like railways, firms who owns or manage with long-term contracts, for example, motorways, highways. That kind of firms are in that situation. They have a good knowledge of their future income, of future cash flows. So they can use, with limited level of risk, they can use more debt and have higher debt equity ratios. So this is what I wanted to do and to show you here. And you understand that you will have to integrate the analysis of financial structure, financial leverage in the architecture we go through for analyzing, making diagnosis, and presenting a scenario, at least, of financial policy for biotechnology, for a biotechnology case. In that case, we don't go into all the details. It means we make hypotheses on the operational structure. We will discuss on the financial structure. It means it's like we consider that the break-even operational leverage is a constant, a kind of parameter, and that the only variable is below the EBIT. We are in that kind of situation. But, in more classical case, you will find probably in the real life, you will have, to try to find the best solution at the same time for the operational and for the financial leverage. Just a few words before moving further on the relations between the operational and financial leverage. And if you are interested in that, you will find then in your textbook in Burke and DeMarzo, it is clear that there is a multiplication effect between the operational leverage and financial leverage. What does it mean? It means if you have a low operational leverage, for example, if your operations are financed mainly by equity, you can consider having a more risky policy on the financial side. On the contrary, if your operations are very risky because you have high fixed costs, and if you multiply by a financial policy with high fixed costs, which is mainly by debt, you will be in a very risky situation. And you can do that only if you have a good knowledge, of your future income and returns. So very often we try to compensate the operational leverage by the financial leverage, that means when the operational leverage is low, we can we have more freedom on the financial policy, we can have high financial leverage, and of course we can have also the opposite policy. This is what I wanted to show you here. So just to summarize what I did there, we went through two elements right now. We have been through an short interest rate analysis. I showed you cases, different situations. And I tried to demonstrate the importance of the level of interest in terms of cost, of course, but in terms of decision, financial structure, and to show you that even in a world which is quite open, the interest rate curve you find in a country are still central elements of a financial structure decision. Second, we try to go through leverages, operational and financial, and concentrated because it is the course on financial leverage, trying to show you the consequences of different debt equity ratios on the return for the company as a whole, on the return for shareholders. We went in a discussion also on the impact of the financial structure on the return for shareholder, and we demonstrated there is one very specific point, which is equilibrium point, where the return for shareholders is independent, is not connected at all to the operational return, but that for interest rates very different from the operational return rate, we have a great impact of the level of EBIT, the level of operational return, on the return for shareholder, the earning per share. Then it is clear that the position and the goals and constraints of different stakeholders are different, and they generally don't fit. They are so different that it's hurt when these different groups of persons are so different in terms of goals and constraints that it's very difficult to find kind of compromise to balance the different arguments. And even some of them, like the bankers, they have internal contradiction. And one of the key of a good management is to be able, to integrate all these elements, constraints, and goals, which are very often opposite, and to find the right compromise to manage the financial policy as a firm as a whole. And this is done through the application of what we call agency theory, which is coming from the economic theory and from an economist called Kölm, K-O-L-M. So this is what I wanted to show you up to now. So we are there, at the point which is here, slide number 17, okay? And you have to move now to find number 18. But slide number 18 is another question. And if you go back to my first slide, you will understand what it is right now. We have to try to formulate, the leverage formula. And after that, the leverage formula will reintegrate all the other formulas we already heard of on valuation and get a first limited set of formula of valuation and of calculation also of the cost of equity. That's what we will do in a few minutes. And if you don't mind, let's have now a short break for 5-7 minutes, as usual, before starting with the financial leverage formula and then the different other models and the questions and perhaps the exercise. Thank you. Short break. ça j'ai ce qu'il faut. Ah. Okay. So I think now we can start again because we have still several topics to go through. I hope you are still able to participate to the course, And what I want to do now, as I said before the break, is to try to show you what is the financial leverage formula and where it comes from. So financial leverage formula first, is trying to simplify and use a presentation, a financial presentation of balance sheet structure. In this presentation, you find on the left side the net assets and the operating working capital. It means you move different categories, Take the assets minus amortization, depreciation, all the accumulated amortization, depreciation, plus the inventories, plus the receivables, minus all the operational debts. And the idea is that it's very close, or it's a good proxy to the investment portfolio of a firm. On the other side, point 3 here, you get the total equity, no change, and the net financial debts. Net means the long, medium, short-term financial debt minus, the cash, which is on the accounts of the firm. So you have a new structure on the balance sheet, but you keep, in fact, the same elements. All the elements, equity, liabilities, and assets are still there. Point 4, the average return of the investments portfolio. It means if you consider that the left side now, net assets plus the operating working capital, is the good representation of the portfolio of investment you call RE, point 4 here, the return. Yeah. And you understand that this return has something to do with the operations. 5, I is supposed to be the average cost of debt. We already know that. 6, S is the cost of equity. And 7, T is the total of the balance sheet. So what to do with these elements? Of course, the return are equal for both sides. The CFO can distribute between the lenders and the shareholders only the value produced, created, or the wealth, as you prefer, by the management of the portfolio of investment. That means the formula is, if you call the left side the portfolio A, the return you produce in terms of monetary unit is A, the total amount of the left side, multiplied by the return of this portfolio, RE. So the cash which is available is A multiplied by RE. And this can be distributed between the lenders and the shareholders. So if the interest rate is high and the level of net debt, net financial debt is D, you have to pay D multiplied by I. and an amount of cash is left, which is different between A multiplied by RE and D multiplied by I. And this is what is left for the shareholder. If the level of total equity is C, you can find easily S, the cost of equity. So S, the cost of equity in this approach, is a residual quantity, and the formula can be written another way, as it is here below. In fact, you get A, but A is also equal to D, the level of debt, plus C, the level of equity, of total equity, because A is equal to D plus C. The total of the left side is equal to the total of the right side, which is D plus C. So you can modify the formula saying, okay, now A multiplied by RE is replaced by D plus C multiplied by RE, and this is equal to what? To D multiplied by I plus C multiplied by S. It doesn't change anything on the right side. After that, it's only calculation. And if you want to calculate S, which is a cost of equity, you isolate C multiplied by S, which is in that case equal to RE multiplied by D plus C minus D multiplied by I. You modify the presentation and develop the right side of the equation, and you get C multiplied by S is equal to RE multiplied by D plus RE multiplied by C minus D multiplied by I. You divide now all these elements by C. You isolate S, you want to measure, and you get S is equal to RE multiplied by D divided by C plus RE minus D divided by C multiplied by I. It means you have taken the preceding line on the right side and you divide all these terms by C. And you can simplify now, saying S is equal to what? To RE plus RE minus I multiplied by D over C. It's just calculation. So the formula you get is quite interesting here. It's quite interesting. This is what we are going to explain and to try to use with a small example. So remember what we did. We said, okay, we have a balance sheet. We have different categories in the balance sheet. That's the kind of categories we have identified to make the calculation of the main equilibriums in financial analysis, net working capital, operating working capital, and T, treasury. Now we can play with these different categories or rectangles in the graph. And we can say, okay, let's put on the left side the net assets. We already have the net assets, plus the inventory, plus the receivables, and minus all the operational debts. It means plus the operating working capital. And this is a good proxy in book value of the level of investments. On the other side, let's keep only the financial resources. Total equity and net debt, with net debt being long and medium-term financial debt, short-term financial debt, minus cash level. And we understand that what we have to do is to maximize, the return on the left side and to minimize the cost of the right side. That's the job, part of the job of the CFO. And we know also that each year, if a firm is profitable, the left side will produce a return, cash, let's say, to simplify, which is equal to the total of the balance sheet multiplied by the return on this portfolio of investment, R multiplied by RE. And this should be equal at the end to the cost of debt, D level of debt multiplied by the average cost of debt, I, plus C, which is the level of total equity multiplied by S, the cost of equity, or return on equity. So S in that kind of presentation is a residual value, residual quantity, and the formula can be written as below. Replace A by D plus C. We have 3 lines before the end of the graph of the slide here, a new presentation. And then we develop this expression, we get C plus multiplied by S, which is equal to RE multiplied by D plus RE multiplied by C minus D multiplied by I. Simplify then, I is net S, and we get at the end S equal RE plus RE minus I multiplied by D over C. What does it mean? It means that the return for shareholder cost of equity is equal to what? Is equal to the return of a portfolio of investment. It is equal to the return on investment, the return on the operations, plus this return on operations minus the average cost of debt. This is what we find between parentheses on the last line, multiplied by D over C, multiplied by the debt equity ratio. So we find again here elements we already know in a different relation. The cost of equity is equal to the operational return plus the operational return minus the average cost of debt multiplied by the debt equity ratio. And this is, of course, very useful. And this is the formulation of what we have shown with the example and with the graph before the break. Now, this formula is here. This is the leverage formula. So, point 2, just what I said, the cost of equity is a function of the operational return and of the financial structure. The operational return and the financial structure. Financial structure is characterized by a percentage of debt, a percentage of equity, and the cost of debt. Point 3, this formula can be used to calculate the cost of equity, but also the return on the investment portfolio, RE. If you know the cost of equity, you can calculate RE. Or if you know RE and S, you can calculate also the average cost of debt. Or if you know all these elements, S, RE, and I, you can calculate D over C. It means a kind of proxy of the optimal financial structure of a firm. 4, remember that RE can be calculated another way. It can be calculated financial analysis ratios. The return of the portfolio of investment can be, remember, calculated both ways, either by the EBIT divided by the net assets plus the operating working capital, or using investment decision criteria, NPV, and taking into account, be very careful because it's NPV per investment, but taking into account the correlations, the covariance measures, using the approaches we use in portfolio management. So, you have different ways to go through. You don't find exactly the same results, of course, because you don't use the same data, they are not based on the same hypotheses, they are not calculated the same way at the same point in time, and so on. But we have good proxies which are generally not so far one from the other. So this is what I wanted to show you on this formula. So you understand that this formula is very useful also in trying to find the best financial structure. Could be very useful on how to calculate the cost of equity, not useful in evaluation models. And it's one of the basic valuation models we have with a simple model. Remember, P is equal to the earning per share multiplied by the price earning. But we have also others. And what I want to show you here, it's another one, which is what we call the Gordon-Shapiro model. And the Gordon-Shapiro model, it's a valuation model which is based on the dividends. If you consider that the price an investor is willing to pay, maximum price is willing to pay, is equal to the future expected dividend discounted at the present time. It means that P1, the price, is equal to D1, let's say the last or the next dividend to be paid, plus D2 for year after, divided by 1 plus S cost of equity square, plus D3 in 4 years from now, divided by 1 plus S 3, and so on, up to the infinite. So you consider the value of an asset, whatever it is true for share, of course, but it is true for any kind of asset, for real estate investment, for example, is equal to the rent or to the dividend discounted to the present time. You get that kind of formula. Now, point 2, and if some of you are interested in that, and you find it in Merck and in Mars also, I can send you all the calculations. But we can simplify. But this formula, this model, is very difficult to use as it is. Just because it's very difficult to find a good forecast of a dividend in the 5 or 6 or 7 years from now. So we have to make our hypothesis and try really to have a formula, a model, which can be used in practice. This is what we call a series. And series, have a characteristic that under certain conditions, they have a good idea to converge. What does it mean? It means under one hypothesis, which is very simple, is that S minus G, G being the long-term growth rate of the dividends. S minus G is positive. The convergence principle shows that we can obtain and use a formula which is that P1, what we are looking for right now, is equal to D1 divided by S minus G. It means the price of a share is equal to the closed dividend paid, or to be paid, divided by cost of equity minus the long-term growth rate of the dividend. That's what we have. This model is, of course, very simple, easy to apply. We have other elements to check below if we want to have a good idea of the quality of a calculation of the results. It's based on the linear regression, and we have to check the quality of the linear regression. We probably made that kind of exam, analysis in your statistics course. This is a problem of distance to the regression line, but also of variance analysis. Let's assume we have good results for these two elements, and then we can use this formula, which means that if you know D1, for example, and P1 before the firm is listed on the mass stock market, and you have found S using the leverage formula, you can calculate G, which is the long-term growth rate of the dividend. If you are in a situation you are looking for value of P, which is not which is belonging to a firm listed on the market, but you were able, to calculate S leverage formula. You know the last dividend D1, and you were able to make the calculation through the regression line, of G, the long-term growth rate of the dividend. In that case, you can use this model to calculate P1 if you know the number of shares, of course, the value of the company. So it's a very useful model you have to know, of course. Now, in fact, we have four men. This basic diagnosis here. You have here four different formulas, right now, and which can be used together. You have a simple classical model we have been through. P is equal to the earnings per share multiplied by PE. If you want to calculate the value of the company, multiplied by number of shares, of course. You have a good knowledge of capital asset pricing model, which is S, the cost of equity, is equal to RF, which is the risk-free rate, plus beta, volatility, multiplied by the expected return of a portfolio of diversified shares. Best thing is to use the futures, of the stock of the best index of the stock market. Have a look to the American and the US stock market. It is the futures on the Standard & Poor's S&P 500 minus the risk-free rate. You know that perfectly. Now we have a Gordon-Shapiro model we just met, with P is equal to D, excuse me, not F. It means the next dividend divided by S minus G. And we have also the leverage formula. We went through and we demonstrated. But never remember, never forget, remember, never forget. But these models are designed with different hypotheses and data. Let's explain we nearly never find the same results for S. However, we can use these models to find the data needed. We will be very careful in the analysis of results, taking into account the bias. Here, when you go through biotechnology, you will be able to calculate S using the capital asset pricing model. You will perhaps on the future period, your scenarios, able to use the Gordon-Shapiro model. And using the leverage formula, able to find an optimal D over C. It means a mix of financial structure. now at that point, I want to give you a few elements on what you have to do. Do you remember this kind of architecture? We made that graph at the beginning of the course, but at the beginning of the course, we had only a few lines, rail lines, on the upper part, west side, left, if you prefer. And we went through the investment decision process and the consequences in the investment plan, said a few words on the debt payment table, and started talking about the investment plan. After that, we added the financial analysis with the three main points indeed here, which are analysis of liquidity and solvency, the analysis of the debt capacity, the analysis of the returns. We have barely been through that kind of elements. We added a few more points here in order to facilitate the last part here. But before that, you will have to do, but you can do it by yourself, if you didn't do that before, through the income statement forecasts. And remember that in that case, we have two different forecasts with two different margins, in fact, which means two different cash flow forecasts at the bottom here. And if you introduce these different cash flow forecasts into the financial plan, of course, you get two different financial plans with two different financial needs. That means that afterwards it will mean two different scenarios here, taking into account, these different financial needs. And you can easily go through, the different steps. The first one being to identify different scenarios. Well, don't take too many, but let's say 2 or 3. A set of criteria to compare the scenarios. Of course, you can use the return for shareholder, but also the debt capacity, but also a liquidity position, for example. And then decide, taking into account this criteria, what is the best scenario. This scenario will be, in that case, made of equity issues, long and medium terms, debt, and perhaps some more short-term debt, particularly in year 3. And then it is the introduction of this policy and its consequences, into the different tables, and this bring you to balance sheet and cash management, and after that to a global financial analysis on the years before 2000 and on 5 years after. That's what you have to do. Of course, you can use, and you should use, all the elements we have introduced in this course. So, on the last 2 slides here, you have kind of a checklist of what to do and not to do. First, calculate the repayments on the past loan contracts to be integrated in the debt payment table. If it is not clear for you, take easy hypothesis. I mean, the question was already raised by some of you for financial analysis. You cannot deduct from the structure you get here the position in the balance sheet at the end of the period before the decision, it means at the end of 2000, because you don't know what is this structure. Make the hypothesis it is constant repayment. It's much simple. And also, you don't know if there was an acceleration, modification of a contract in the meantime. If you have flexibility in your loans, perhaps you have accelerated or you have decreased the repayments. It's very difficult to connect to balance sheet, or you had to know all these specific operations. Second, calculate the depreciation on the investment to obtain the depreciation table is easy to do. You have the rules there. Third, prepare the income statement forecasts, introducing the last line of the depreciation table. Now, there are two hypotheses, optimistic and pessimistic. And you will obtain the cash flows for H1 and H2, the two hypotheses. Then you can move to the financial plan and design the financial plan with two hypotheses. The last line of the investment plan is very useful for you and will be introduced into the financial plan. The last line of the debt payment table or repayment table also, and of course the cash flows. In fact, it is in its structure, it's a very simple financial plan with the last line of the investment plan, the last line of the debt payment table, and the cash flows obtained from the income statement forecast. And as you get two different lines of cash flows, you need two different financial plans. And in each case, you will calculate the financial needs for each year and also the cumulated financial needs. And you are mainly interested by the cumulated or accumulated financial needs. This is what you have to manage afterwards as a CFO. My last line here is about complementary elements. Check the liquidity and solvency constraints. That's what we have done with financial analysis. Second, measure the return level for shareholders. Okay. Measure also the debt equity ratio and the debt capacity. Write the diagnosis taking into account the preceding calculations, but in fact, you already did that. Now this is completely new. Design financial policies scenarios. And then compare them with a set of criteria and choose, make a selection of a financial structure. That's really what you have to do. And if you go further, which is a bit more complex, you should integrate the new resources into the architecture. That means you have loops. You have to go back to the repayment table. You have to go back to income statement, to financial plan, and try to make to find the right equilibrium. And what you can do if you go to the end of the process is to adjust the cash management policy and extend the financial analysis in order to get a financial analysis on 8 years, 3 years before the decision and 5 years after. So that's what you can do. And I'm waiting at least you do part of that. Because point 8 and point 7 and point 8 are quite difficult to go through. Perhaps you will bring some elements here, but probably will not go to the end of the calculation. But it doesn't matter. You have to understand what it means. And if you understand very well the different technical elements separately, and after that, what it means, what it means in terms of structure, this will be very, very good. So I mean, pretty issues, there's a mistake there. This is something I should not have done. 94, 13. My God. Okay. So now what I want to do is to come back to this element. I want to come back here because after doing this presentation, you know, with the interest rate, with the financial leverage, operating leverage, the calculation with the exercise, the graph, the formula. I move to the golden Shapiro model on dividend and introduce, you know, a summary of 4 main models. I want you understand very well where how we can move from one to the other, even if you have mistakes, bias inside. But this is not the problem, you know. I want you also to understand how you can connect financial analysis and the investment decision criteria you started with, Olivier Gozard. And I try to come back and integrate all that into the architecture of a financial policy I presented you during the first session, and I showed you the different steps to go through. I'm waiting from you that you are able to make a diagnosis, to design the income statements, financial plans, choose and explain a financial policy. It means a mix of equity and new loans, and perhaps are able to go further, at least on some of the consequences, even if it is probably difficult. Now, I wanted to come back on one of the elements we went through earlier. I am back now on other slides, you know, and these other slides, I hope you see them here, you know, they are, you know, advanced financial policy and diagnosis. It was a set of slides I used, you know, in session 1 to 3, and I never finished that. I said, you know, I will come back on the what calculations. And there was an exercise there. There was an exercise. I started by the beginning here of this exercise. I started by the beginning of the exercise. And it should be, I should start with 26, I think. Yeah, we started there. We went through a few calculations on the cost of debt before taxes. And it is exactly, if you want to show the elements more precisely, it's a kind of byproducts of June 19, part 6. June 19, part 6 has just modified the elements of the amount of debt. If you have a look to this exercise as it is in the exam, we have 3,000 and long term. I've got here 6,000. We had 4,000 and medium term. I've used 3,000, and we had 3,000 short term, and I have here 1,000. All the other elements and questions are identical. So if the slides are not enough clear, on the data. You can use the June 2019 part 6. That's what I showed you already was this calculation of the cost of debt, average cost of debt before taxes. And our conclusion was here that the average cost of them is always before the extreme cost of debt, generally the long term and the short term, and that also short-term interest rates are lower than medium-term interest rate and long-term interest rate. With R.5 and 0.7 here. Let's move to the second slide, and the second slide is about the profitable, the non-profitable case. And what I said and demonstrated is that for after taxes, for a non-profitable company, the cost of debt is the same than before taxes. For profitable company, it's different. And what you see, if it is 0.4 and 0.5, is that the cost of debt after taxes for profitable firms is lower than before taxes, and that also the cost of debt after taxes for profitable firms is lower than the cost of debt after taxes for non-profitable firms. You have two data here, 3.6, and the other one, which is 4.8 on the preceding slide. I have to compare. Then we moved to the introduction of the leasing contracts. And we said, remember that we have two cases, operating and financial lease, and we take into account the equivalent debt of the financial lease contract. Made the calculations, we had 7% on 5,000, which is 350, and the total cost before leasing, which was 480. We added both data, we got 830, and now we have 10,000 plus 5,000 equivalent debt. You calculate the cost, it is 553, and this is before tax. And then we moved one step further, and we said now we have to calculate the cost of debt after tax and leasing included, and it is the last data, 553% multiplied by 0.75, which is 1 minus 0.25, 25% tax rate, which is 415. This is what you find here on the third line, third part. So we got, in fact, 4 different data, 4.8, 3.6, 5.53, and 4.15, which are all of them easy to interpret, note. The first one, 4.9, is before leasing and taxes. Second one, 3.6, is before leasing and after taxes. 5.53 is after leasing but before taxes, and 4.15 is after leasing and after taxes. So we understand that in these calculations, the leasing contracts increase the cost, the tax rates has a positive influence on the cost. It has for consequence a decrease in the cost of the debts. Now we have to move to the WACC calculation, and you remember that we had in the exercise 10,000 equity, total equity, that's total equity. And we have a cost of equity, which is calculated another way, perhaps by a capital asset pricing model, or by using a leverage formula, or even Gordon-Shapiro model. So we make the calculation, 10,000 multiplied by 16% is equal to 10,000 multiplied by 4.8. Is calculation before before taxes and before leasing here. Make the calculation, 1,600 plus 480, which is 2,080. And with now a WACC, a total amount of resources, which is 10 plus 10, which is 20,000, we get 10.4 for the WACC. Now we introduce another calculation with leasing contracts, it was before, and after taxes. And in that case, we still have the same element for the cost of equity. It doesn't change, no impact. But we have here 3.6 instead of 4.8, and we get 9.8%, same kind of calculation. So this means that the higher the tax rate, in fact, the higher the tax rate, the lower the WACC is. What does it mean with that kind of relation? Higher the tax rate, the lower WACC. A CFO in general wants to minimize the WACC because he knows that the WACC is going down, net present value of portfolio investment will increase, the value of the company will increase. So it seems, it's good news to have a higher tax rate than before. But goes without any change, any other modifications, you increase the value of the company. That means, in some way, the decision for Ministry of Finance to increase the tax rate, is an incentive to finance the firms like that. And we know that, on the other hand, very often there is a message coming from public authorities and government to finance more the firms by total equity. So there's a kind of contradiction. Again, it's agency theory behind. Different incentives, contradiction, position between the incentive, which is not good for managing the firms. And that's happened in many countries. So now you can do the same calculations I did, in the preceding slide. Leasing included before taxes and leasing included after taxes. And if you go through this calculation, you find 9.71, 8.89%, same thing, the higher the tax rate, the lower the WACC is. 8.89 is lower than 9.71. And you understand that in these calculations, we have higher cost of WACC with leasing than without leasing. But we have admitted here that there is no swap between leasing contracts and equity. But if you say, okay, I don't modify my total level of investment, but I increase my debt capacity using more leasing contracts and less equity. It means if leasing contracts replace part of the equity, in that case, you will have a decrease in the WACC. You will have an increase in the cost of debt, but a decrease also in the WACC. So some of its conclusions, back on that slide here, that increase reduces the WACC and increases the return up to a limit because there's a limit. Remember what we stand on the limit of the debt equity ratio with junk bonds and risk premium. Second, an increase in the tax rate reduces the cost of debt and the WACC and increases the return on investment. Third, public policies very often give firms incentive to finance companies by equity to reduce the risk level and increase their sustainability, but also increase the tax rate to get more budget resources. Okay. And this is the last one. And I want just to come back on something different. If you go back and you find this, it is question 4, part 6 of June 2019 exam. This is another example of multiplier and discussion on models. So the example here, it's exactly what you find. Question 4, part 6, June 2019. Dividends is €6, payout ratio is 30%, and PE is 50. So what we want to do is first to calculate, the earning per share. It's quite easy. The earning per share is equal to the dividend divided by the payout ratio. Remember what we have done on that. It's not just the other way around. And if you divide 6 by 0.3, you find €20. The earning per share here is €20. Okay. After that, the earning per share being €20 and the dividend being 6, that means that return earnings is equal to the difference, is equal to €14, 14.3. If you apply the simple model, you find P, the price of share, is equal to the earning per share, 20, multiplied by the PE. Now there's a mistake there, sorry for that. There's a mistake, 0.4. It is equal to 20 multiplied by 15, which is equal to 300. Here we'll make a correction. 5, according to this model, with price and value are explained by the PE in the short term. It means, in the short term, the changes, modifications are due to the price earning. And price earning changes are due, as we know, to the interest rate modification, into budgetary decisions, to bank's difficulties, and so on. But in the long run, it is mainly explained by the earning per share. But if you move to point 6, you understand that according to different other models, the Gordon-Shapiro models, for example, we have seen, the price and the value of companies are explained by other factors also, like the firm growth of dividends and the cost of equity. So what we have here is a classical approach. You know that very well because we have been through several times. Okay. But we have other approaches. And in fact, the number of elements, parameters, factors having an impact and influence on the valuation models is not only limited to the PE level and the factors behind, like the interest rate, long-term interest rate, or the evolution of a return, operational return, earning per share, but also are connected to the dividend policy, for example, and by the cost of equity. So that means in the future, calculations will go through, will introduce more elements which are integrated in the different models, the 4 models I just presented you, and it will be part of the first session of the company valuation course. We had discussion and applications. It means extensions and integration of these models into the valuation of a company. It means a kind of better, simple model. But what we have applied here from question 1 to question 4. So this is what I just wanted to present you today. You will find also in my presentations, these exams, 2019, 2020, they give you, we have been through some of the questions there, but we find other questions could be useful for the preparation of the final exam and in order to better understand, which is a goal. And goal is not the exam, the goal is to understand and to be more expert in finance, and to better understand and discuss perhaps with your colleagues some of the points we have been through. So what I tried today to do and to go through was first some elements on interest rates, interest rate curves, the impact, what they are used for, to manage long-term, short-term. How can they explain also the evolution of interest rates and also the cost of equity? Second, we went through the financial and operational leverage, tried quickly to explain how they are connected, and use an example in a graph to introduce financial leverage, and after that we move to the formula. And formula is a good formula to connect the cost of equity and the factor like the financial structure, debt equity ratio, and the relations between the operational return and the average cost of debt. And we decided to put on the same slide, 4 basic models. There's one, the simple model you already know, and two, the capital asset pricing model you already know. And last, the Gordon-Shapiro model I introduced today. And in order you reintegrate all that, because just remember that was explained very well by Olivier Rosard, the what calculation is very essential because of the NPV calculation afterwards. We went to an exercise we began those 2 questions 2 sessions ago, and went through again, calculated the what, measured the influence of the financial structure using leasing. It can be done with some other hybrid products. So we do that in the 2 of the courses on the valuation and M&A. And also it was a good opportunity to show at the same time what they bring, but also the limits, the bias of these different models. That's what I try to show you today. So we are at the end of the course now. I hope you learned something from that course, at least, you were interested in what we did, even if it's not so easy through internet and Zoom. We'll be come back together in a few weeks for the company evaluation course, and then for just before the end of the year for the M&A course. I hope that later, particularly we work and defend your thesis, will be able to meet in the classroom in Hanoi and Ho Chi Minh City. But this is still the situation. So thank you very much. Take care, work hard, and I think we will succeed. You will succeed in the program. You will succeed also against the pandemic. Hope to see you physically in the classroom as soon as possible. Goodbye. Thank you. Good night. Sleep well.
Thank you, Professor.
Thank you.
Professor, are
Yeah.
you still there? Can I ask something about the assignment for FA1? Because
For assignment for what? For
the
FA1.
yes, the FA1.
Yeah.
I want to ask if is it correct that only the question 1 and 2 was for FA1 and the 3 and 4 for FA2?
Yeah. For FA1, yeah, it was mainly question 1 and 2 because there were 2 questions on financial analysis, you know. For this course, which is a course financial policy, in fact, it fits very well with question 3, question 4, and perhaps question 5. But don't take into account question 6. We will go through question 6 in the company evaluation course.
Okay, thank you, sir. I just want to confirm again.
I can send an email if it's not clear for everyone. I can send an email to Tram.
That would be great, sir.
Okay, I will do that.
Thank you very
Perhaps
much.
not today, but tomorrow. I will do that.
Thank you.
Thank you. Anything else? No. So goodbye.
Thank you, Professor. Goodbye.
Thank you.